Our lesson for 5.7 is going to have us graph quadratic inequalities, and then also we're going to solve quadratic inequalities and display the answers in interval notation. Now we've done inequalities for linear expressions, but never for quadratics. So this is going to combine what we know about our quadratics and what we know about inequalities. So first, I'm going to have you graph y is less than or equal to x squared. Well, the first thing we have to think about is whether the boundary line is going to be solid or dashed. And since we have an equal to symbol, less than or equal to, the boundary line will be a solid line. So let's keep that in our brains. And then the next idea is, how do we graph the function? So if I just gave you y equals x squared as an equation, and I asked you to graph that, well, you could do this a couple of different ways. You could just realize that this is a basic quadratic. You could make a t-table for yourself. You could go to your calculator and pull up a t-table. So I know that this is a basic quadratic, has a vertex at 0, 0, and if I think about plugging in some numbers, my vertex is at 0, 0. If I go 1 to the left and 1 to the right, whoops, positive 1, excuse me. Negative 1 squared is positive 1, and positive 1 squared is positive 1. So when I plot those 2 points, and remember we said the boundary line should be a solid curve as opposed to a dashed line. Alright, now we're not quite done. The idea for the inequality is we're either going to shade in one of the two regions. There's two regions now on this graph. The region that is inside the parabola and the region that is outside the parabola. Well, the easiest way, in my opinion, to figure out whether we should shade inside or outside is to test a point. So I'm going to test a point that's obviously on one part of the boundary, inside the parabola or outside the parabola. So I'm going to test the point 4, 0, because I can tell very easily that this point right here, 4, 0, is outside of the parabola. So if I plug in a 4 for the x and a 0 for the y into my original equation, I'm going to get 0 is less than or equal to 4 squared. So is 0 less than or equal to 16? Yes, it is. That's a true statement, which means that the point 4, 0 is part of the solution, which means I should be shading outside of my parabola. And that's what your answer looks like for number 1. When I look at number 2, the first thing I notice is there's no equal to bar. So I have to write myself a little note, because I tend to forget that this boundary line is going to be a dashed line. So now I think about how I'm going to graph the parabola x squared plus 4. Well, that's a standard parabola who's been shifted up 4. So instead of having a vertex at 0, 0, he has a vertex up here at 0, 4. And then if I try to pick some points that are to the left and to the right of that vertex, negative 1 squared is 1, plus 4 is a 5, and then 1 squared plus 4 is also 5. So remember, we said this curve was supposed to be a dashed line, so make sure when you draw in your parabola, you've got a dashed line. And now I'm going to test a point. This time, I'm going to test the point 0, 0, who's obviously outside of my inequality. So I'm going to go ahead and plug in a 0 for the x and a 0 for the y. 0 greater than 0 squared plus 4. So the question is 0 greater than 4? And no, that is not true. That is false. Which means that 0, 0 is not part of the solution, so that means the other region inside the parabola would be the solution. So you're going to shade inside of the parabola. Now, it didn't matter what point you tested, as long as you could tell whether it was inside or outside of the parabola. So for number 3, we're going to have another dashed line. I'm going to write myself a note so I don't forget. Dashed curve, I should say. And this time the parabola has been shifted up 2, and the other issue is that he's been reflected upside down. So maybe you already kind of know what it looks like. And if you don't, you could just make yourself a little t-table again. And say, if I pick 1 to the left and 1 to the right, negative 1 squared is positive 1, but remember there's a negative outside, so it's really now a negative 1 again. Plus 2 gives me a positive 1. So, remembering that this is a dashed curve, draw in your parabola. Hopefully yours looks better than mine. You know my curves never look great. And then I'm going to test a point. I like to test the easiest point I can think of, so in this case I'm going to test 0, 0. Is 0 less than, negative 0 squared is still going to be a 0. So 0 less than 2, and yes it is. So this is part of the solution, the point 0, 0. So that's where I'm going to shade, is underneath this parabola. Alright, moving along. Example 4. Let's see, this time you might notice that this is in technically standard form. So you have a couple of different ways that you could figure this out. You could say, alright, I'm just going to grab my calculator and figure out how to graph this. That's fine. The other option is you can say standard form, I can find the vertex by taking negative b and dividing it by 2a. So for our problem, negative b would be a positive 4, and then 2 times a would be 2 times 1. So my vertex has an x value of 2, and then remember to find the y value. You went ahead and took that 2 and you plugged it back into the original equation. So 2 squared minus 4 times 2. So 2 squared is 4, minus 8 is negative 4. And again, this might not be the quickest way for you to do this. If you have a graphing utility at your disposal and you would like to use it, by all means, go ahead. So if I pick something to the left and to the right of my vertex, when I plug in a 1, I get 1 minus 4, which is negative 3. I'm going to get the same thing when I plug in a 3. So at 1, negative 3, whoops, at 2, negative 4, and at 3, negative 3. Excuse me. We have a parabola, and I didn't make a note earlier, but this is a solid parabola this time. So I'm going to go ahead and graph this in. Oops, do a better job than me. There's my parabola. Now again, I'm going to need to test a point, and I'm not really certain that I graphed really carefully, so instead of testing 0, 0, because I think he actually goes through 0, 0, I just did a bad job of graphing, I'm going to test something that's really obviously on one side or the other. So I'm going to test the point 2, 0, which is this guy right here. I can definitely tell he's in the middle of the parabola. So if I plug in a 2 for the x and a 0 for the y, I get a 0 greater than or equal to 2 squared minus 4 times 2. So is 0 greater than or equal to 4 minus 8? And yes, it is, because 0 is bigger than a negative 4. So since that's true, we're going to go ahead and we're going to shade inside the parabola. That would be my solution set. There's a whole lot of answers, that's why I can't just give you one answer. Now the next problem, again, it's in standard form, so maybe you want to find the vertex that way. The vertex, actually let's do this one another way. I'm going to factor out the x and rewrite it as x times x plus 3, and now it's in intercept form. So my two x-intercepts are going to be at x equals 0, and the other x-intercept is at negative 3, if I were to set these two equal to 0. I'm just, for a little variety, I'm changing it up the way we're going to solve this one. Now remember, our vertex is always in the middle of those two intercepts. So right smack dab in the middle of 0 and negative 3, if I add those together and then divide by 2, I get negative 1.5. And then if I take negative 1.5 and I plug it into the original equation to find the y value, I get negative 2.25. So I'm going to graph. Oops, I did not graph that right to begin with. Excuse me. Negative 3 would be over here, Mrs. Abruzzo. Okay, negative 1.5, negative 2.25. Roughly there. This is a solid parabola, because it's equal to. Ooh, do a better job than I just did. And then I'm going to test a point that's obviously to one side or the other. So I'm going to test the point 3, 0. Because I can definitely tell he's outside of the parabola. And if I plug in a 3 for the x and a 0 for the y, I get 0 less than or equal to 3 squared plus 3 times 3. And that is most definitely true. 0 is bigger. 0 is less than, 9 plus 9. So since that's true, we're going to be shading outside of our parabola. And all of those are going to be your answers. I really messed that up, didn't I? Okay, moving on. Now, it's very likely that we split this lesson up into 2 days, so if you need to stop here in the notes, go ahead, otherwise continue on. Now we're going to solve a quadratic. Instead of graphing it, we're actually going to give the solution set as our answer, and we're going to do it in interval notation. Now, to solve a quadratic inequality, we're going to give you 2 methods. The first method is through graphing it, and the second method will be algebraic. So first, this time I still give you a parabola or a quadratic, x squared minus 6x plus 5 less than 0. And I'm going to go ahead and just graph the original parabola, x squared minus 6x plus 5. Now, I don't really mind what method you use to graph this parabola. You can use your calculator, you can say it's standard form, maybe you decide you want to factor it. I'm going to go ahead and factor it, and actually it really does work out nice if you factor it. So let's see here. We've got an x minus a 1 and an x minus 5 if I factored that. So my 2x intercepts are at x equals 1 and x equals 5. The reason it's really important that we know where x-intercepts are is because that's going to be the point where our intervals are going to take off. Now my vertex, remember, is in the middle of 1 and 5, so 1 plus 5 is 6. Cut that in half, you get a 3. And if you plug in the 3 to the original parabola, you're going to get a negative 4. So whatever method you wanted to use, I want you to graph that parabola. And it doesn't have to look real pretty, because, oops, our solution is actually not the graph. Remember, the original problem says they want to know when the parabola is less than 0. So less than 0 means they want to know when the parabola is negative. So look at your graph and decide which part of the parabola shows you negative solutions. Negative in our case would be below the x-axis. So I should do an open circle here. This whole section right here over the parabola is the negative part. So we need to write that answer in interval notation. So if we think about the domain, it goes from 1 to 5, and because it doesn't have an equal to symbol, that's going to be your interval. From 1 to 5 with parentheses, not brackets, because it's not equal to 0. Okay, our next parabola, I'm going to factor it again to find my 2x intercepts, because that's going to be the point where our interval begins and ends. So let's see, we have a 2x and an x, and how about we do a minus 3 and a plus 1. Let's see, that should work. It'll give us a negative 6 and a plus 1. So my 2x intercepts are at negative 1/2 and positive 3. So positive 3 and negative 1/2. And then your vertex, which you can find a couple of different ways. I'm just going to kind of cheat and use my calculator to find the vertex quickly. I get a 1.2 and a negative 6.1. The reason I'm not too careful about finding the vertex really has nothing to do with whether the parabola is greater than or less than 0. It's really the x-intercepts that are important. So I'm just kind of finding the vertex to give me a rough look at what this graph looks like. Oops. Let's try that again. Okay, so anyways, they want to know where this parabola is greater than or equal to 0. So in this case, they want to know where this parabola is positive, because greater than 0 would be numbers that are positive. So when I look at my graph, the parts of the parabola that are positive would be the branches that are above the x-axis. So right here and right here. So if I'm going to write that in interval notation, I'm going to say that it goes forever to the left at first, so negative infinity, all the way until you get to negative 1/2. Now, because they have an equal to 0 symbol, we're going to put a bracket on the 1/2. And then because I need to jump, we're going to put a union, meaning it jumps over all this middle part and then picks up again with a bracket at 3 and then continues on forever to infinity. So the interval where the function is positive would be negative infinity to negative 1/2, union 3 to infinity. So that's the graphical method for finding out where the functions are positive or negative or greater than or less than 0. And we have an algebraic method now, and it's not necessarily up to you how you find the answers in some cases, because on your homework I am going to ask you to do both, so make sure you have a good grasp of both. So first, the directions say find the zeros of the function, and then we're going to test values on a number line. I kind of like this method. I think it's fun. So finding the zeros mean to factor. So if I tried to factor x squared minus 2x minus 8, we get x minus 4 times x plus 2. So my two intercepts are going to be at x equals 4 and x equals negative 2. So on your number line, go ahead and fill those numbers in, leaving space in between. And what I'm going to have you do is test a point within each of these intervals. So first, in this interval right here, to the left of negative 2, you can test any number that is smaller than negative 2. So I'm just going to be really easy and test a negative 3. If I were to plug in a negative 3 in for x squared minus 2x minus 8, I would get negative 3 squared minus 2 times negative 3 minus 8. And it's not so important that you actually know the number you get, but you need to know whether the number is going to be positive or negative. And it turns out the number here turns out positive. No matter what number you plug in, anything less than negative 2 will end up being a positive answer. Now the middle section here, we need to test a number that's between negative 2 and 4, so I'm going to test my friend 0. If I plug in a 0, I get 0 squared minus 2 times 0 minus 8, and I get a negative 8, which is obviously a negative number. And then above 4, anything above 4, well, I'm going to test a 5, because I don't feel like thinking too hard. So if I plugged in a 5, I get 5 squared minus 2 times 5 minus 8, and I get a positive answer. And you're going to notice that they alternate in sections. It'll go positive, negative, positive, or it'll go negative, positive, negative. So the two places that, remember, we're looking for where it was greater than 0 or positive would be this section right here and this section right here. So we need to write our answer in interval notation. So anything less than negative 2 would be negative infinity to negative 2. Now because it does not have an equal to symbol in the original problem, we're going to put a parenthesis. Union, I got to jump over all this negative business in the middle. And then it picks up again at 4 and goes to infinity. So our final answer is that lovely interval. I kind of like that method just because I can factor pretty easily. So it almost feels like a waste of time to graph it if I don't have to. Now number 9 is a little more complicated just because the factoring is more complicated. So when I try to factor 3x squared plus 7x plus 2, I get 3x and x. And let's see, if I put a plus 2 and a plus 1, that'll be a plus 6 and a plus 1. So my two x-intercepts are negative 1/3 and negative 2. So make sure you put them in the right spot. There's negative 2 and there's negative 1/3. And if I start testing some points to the left of negative 2, I'm going to test a negative 3. When I plug in a negative 3, I get a positive answer. So when I stored it or I just plugged it in my home screen or thought about it, I got a positive number. When I test something between negative 2 and negative 1/3, I'm going to test a negative 1. And I end up with a negative number when I plug in a negative 1. And again, remember, these should always alternate. That doesn't mean you should assume that you did it right. I want you to go ahead and make sure they all test out correctly. Anything bigger than a negative 1/3, well, I'm going to test a 0 because that's easy to plug in. And I get a 2, which is a positive answer. So this time in the problem, they were looking for places where your function was less than or equal to 0 or negative. So the section we should be looking for is right there. And because it has an equal to bar, we're going to put brackets on it. So from negative 2 to negative 1/3 would be our interval where our function is negative, actually, not positive, negative. Okay, that concludes our lesson on 5.7.